Hi students, this is Srikanth and today we are going to discuss one of the interesting chapters of mathematics from 10th class, and that is sets. So children, if you are asked to describe a person, how would you do that? For example, Srinivasa Ramanujan. Srinivasa Ramanujan is a mathematician and interested in number theory. Potana was a great Telugu poet and also a devotee of Lord Rama. Abdul Kalam was a scientist and former president of India. So children, we classify the individuals with specific characters like Ramanujan, mathematician, Potana, poet, Abdul Kalam, scientist. So, even in your subject of mathematics, your subject is divided into 14 chapters under various titles. So, mathematics is no different from others. It needs objects to be collected into meaningful groups. For example, the groups of numbers that we generally use in mathematics are n is the collection of natural numbers. Collection of natural numbers like 1, 2, 3, so on. That is n. Next, W is the collection of whole numbers like 0, 1, 2, 3, so on. So, next, Z is the collection of integers like 0, plus or minus 1, plus or minus 2, plus or minus 3, so on. And next, Q is the collection of rational numbers that is. So children, you must know what are rational numbers. Yes, rational numbers are the numbers which can be written in the form of P by Q, where P, Q are integers and Q is not equal to 0. Let me write the same thing. That is, the numbers that can be written in P by Q form, where P, Q are some integers and Q is not equal to 0. So such collection of numbers is called rational numbers. And then R. We have discussed this in your previous chapter, real numbers. R is the set of real numbers. So R is the collection of real numbers. So children, what are real numbers? All the natural numbers, whole numbers, integers and rational numbers all together is real number set. So real numbers are the numbers which can be written in decimal form. Real numbers is a collection of real numbers that can be written in decimal form. So children, now let us see one task. Identify and write common property of the following collections. So previously we have seen the collection of numbers that we use in mathematics. Now here some sets are there, some collections are there, and we are asked to write the common property of that collection. Now here the first one goes like this: 2, 4, 6, 8 and so on. So children, try to catch what is the common property of this collection of numbers: 2, 4, 6, 8, and so on. Yes, these are all even numbers or multiples of 2. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8. All are even numbers. So the common property is they are all even numbers, or you can write multiples of 2. Now let's see the second one. 2, 3, 5, 7, 11. What must be the common property among this collection of numbers? Yes, children, they all are primes or prime numbers. We know a prime number is a number which has only two factors, 1 and itself. Yes. So 2, 3, 5, 7, 11 are prime numbers. Yes. And now, children, this 2 is a special prime number. Can you tell why? Yes. All the prime numbers are odd excepting 2 because 2 is the only even prime number. That's good. Now let's see the next one. 1, 4, 9, 16 and so on. What these numbers are? What must be the common property? Yep. See here. 1 square is 1. 2 square, yes, 4. 3 square is 9. 16 is the square of 4. So 1, 2, 3, 4 squares. 1 square, 2 square, 3 square and 4 square. That means these are all squares of natural numbers. Squares of natural numbers. Yes. Now, January, February, March, April and so on. Yes, children, we all know that these are the names of months of an year. Yes, let me write the same thing. So these are all months of an year. Right. Now the last one is thumb, index finger, middle finger, ring finger, pinky. Thumb, index, middle, ring and pinky. Yes, children, these are all fingers of hand. Yes, let me write the same thing here. So that means we can able to find the common property of collections of objects. So yes, children, we have seen collection of some objects like 2, 4, 6, 8 and so on. There we can find the common property of those numbers, like they are all even numbers or some prime numbers or some names of months or the names of fingers of a hand. So if you define a well-defined objects, if you collect, such collection is called a set. So let us define what is a set. A set is well-defined collection of distinct objects, like all the names of months or the names of subjects in 10th class. So they are all well-defined collections. If I say Ramesh and January, is this collection gives you a meaningful group? No, because Ramesh is the name of a person, January is the name of the month. So the collection of these two things do not make any meaning. So if we write a meaningful group means a well-defined collection of objects, then such collections are called sets. So once again, children, the definition of sets is a set is a well-defined collection of distinct objects. So children, these objects which are placed in the set are called elements of the set. And generally we write these elements in an enclosed brackets like this. And every set is generally denoted by a capital letter of English alphabet like A, B, C, D, X, Y, Z. Right. For example, let me write one set here. See, set of first 5 prime numbers. So let me write a set of first 5 prime numbers like this. P is the set of prime numbers. So it is enclosed between the brackets. So what are the prime numbers? First 5 prime numbers. 2, 3, 5, 7, 11. 1, 2, 3, 4, 5. Yes, and close the bracket. Now this is P is the set of first 5 prime numbers. So these numbers are the elements of the set and they are written between the brackets, and this set is denoted with a capital letter of English alphabet. So we have learned the definition of set. Now let us try some of the examples like this. Set of first 5 positive integers. Let me write the set. Set of first 5 positive integers. So children, we know we have to write the elements in the closed brackets. So set of first 5 positive integers. What are the first 5 positive integers? +1, +2, +3, +4, +5. Or you can simply write 1, 2, 3, 4, 5. Set of first 5 positive integers. Next one, set of multiples of 5. So 5 multiples we have to write, and there is a condition still here, which are more than 100 and less than 125. So the multiples of 5 must be more than 100 and less than 125. Let me write this set. Set of, so more than 100, 105, 110, 115 and 120. Next one is 125, and he asked us to write less than 125. So still till 120 only we can write. So that is the set required. Now here the third one, let us see. Set of first 5 cubic numbers. So we have to write the cubic numbers. Let me write here. 1 cube is 1 and 2 cube. 2 2s are 4, 4 2s are 8. 3 cube, 3 3s are 9, 9 3s are 27. 4 cube, 4 4s are 16 and 16 4s are 64. And the last one, 5 cube, 5 5s are 25, 25 5s are 125. So this is the required set. Now the last one, set of digits in the Ramanujan number. So children, we know what is the famous Ramanujan number. It is 1729, 1729. So let me write. And that we have to write set of digits in that number. So how can we write like this? Set of 1729. So we have learned to write the sets. So how are we writing the sets? We are writing the sets by listing all the elements in the set. Like the first 5 prime numbers means we wrote all the first 5 prime numbers 2, 3, 5, 7 and 11, which are separated by commas. So writing a set in this manner is called roster form. So we can write a set in roster form where all the elements of the set are listed and separated by commas. For example, let's see here. Once again, let us write the same example. So set of like this. P is the set of first 5 prime numbers. So let me write here, P is equal to set of first 5 prime numbers 2, 3, 5, 7 and 11. So we have written all the elements in the set, and each element is separated with a comma, and they are enclosed in the set brackets or curly brackets or braces. So in this form of writing a set is called roster form. Okay, and now let us see the belongingness of the elements of this set. For example, if I take the element 2, can you say 2 is 2 an element of the set P? Yes, 2 is the element of the set P. If I say 1, 1, is it an element of set P? No, it's not an element of set P. So we can write this belongingness of an element by using a symbol like this. And this is called belong to. So we can write, if 2 is the element of P, we can write 2 belongs to set P. And 1, is this belong to set P? No. So we will write 1 does not belong to set P. Furthermore, let's see, like 3 belongs to P. 4 does not belongs to P. Okay, so if you write the set in its roster form, we can write the belongingness of the elements using these symbols. So this symbol is read as belong to, and if the symbol is cancelled, now this symbol is read as does not belong to. Suppose children, if you are asked to write the set of rational numbers in roster form, set of rational numbers in its roster form by listing all the elements of the set. Can you try that? Yeah. So we can conclude that we cannot write the set of rational numbers in its roster form, means we cannot list all the elements of it. So how can we represent this set? So we can write the set only by defining its elements with a common property. If you write a set by defining its elements with a common property, then such way of writing a set is called set builder form. What is a set builder form? Set builder form means when we write a set by defining its elements with a common property, as we discussed in the early part of this lesson, the common property. So we can say that the set is in the set builder form. Let's write the set builder form of rational numbers set. So Q is the set of rational numbers. So as we already discussed that it is not possible to write the set of rational numbers in roster form. So we can write only in set builder form. How are we going to write? Let's see here. Q is the set of, so Q is equal to set of rational numbers. What is the common property of rational numbers? Rational numbers can be written in P by Q form only, where P, Q are integers and Q is not equal to 0. So that is the common property, and let me write this set builder form. Let's see here. Q is equal to X. So X is the elements of the set Q, okay? Such that, so this is read as such that X is equal to P by Q. That means these elements of Q should be in the form of P by Q, where P comma Q are integers and Q is not equal to 0. So this is the way of writing set builder form. So let's see here and how we have to read this one. Let us see once again. Q is the set of elements X, where X is equal to P by Q. P and Q are integers and Q is not equal to 0. Let us observe some of the sets in their roster forms and set builder forms. Okay, now here is our first set. V is equal to set of A, E, I, O, U. Children, can you say in which form is this set written? Yes, it is written in its roster form. Why? Because all the elements are written and they are separated with commas, right? So what must be the set builder form for this? Carefully look into the elements of the set. A, E, I, O, U. What are these letters? These are from English alphabet and they are vowels. Yes. So how are we write? We are going to write the set builder form for this set. See here. V is equal to set of X such that. So every time we have to mention X. X is the element, right? So V is equal to set of X such that X is a vowel in English alphabet. So that is the way of writing set builder form for that. Now let's see second set here. A is equal to set of -2, -1, 0, 1 and 2. So this is the roster form. So let us see the elements which are written in the roster form are some minus numbers, some plus numbers and 0. So we can easily say that these are all integers. But all integers are not mentioned here. Integers are from -2 to +2. So how can we write the set builder form? Let's see here. A is equal to set of X such that, see the integers are from -2 to +2. I mentioned here. -2 is less than or equal to X is less than or equal to 2. So X is in between of -2 and +2, including them, and X belongs to Z. Children, we know Z means set of integers. So all are integers and they are from -2 to +2. That is the way of writing set builder form. Now the third set, let us see. B is equal to set of 1, 1 by 2, 1 by 3, 1 by 4 and 1 by 5. See, if we see carefully into these elements, if we observe these elements, we can say that they are all in P by Q form, right? But all the numbers are having numerator 1, 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. So numerator is 1, that is fixed, and the denominator 1, 2, 3, 4, 5 means the denominators are natural numbers. So how can we write the set builder form for this roster form? See here. B is equal to set of X such that, so these two dots means such that we have to read it as X is equal to 1 by N. See children, are they not in 1 by N form? Yes, they are. So X is equal to 1 by N, where N belongs to natural number set. Capital N means natural number set. So the denominators are all natural numbers, 1, 2, 3, 4, 5. But how many natural numbers we have to write here? N is less than or equal to 5, means up to 5 only we can write. So this is one. Next, last set in roster form from this task is C is equal to set of 2, 5, 10, 17. See children, here these elements are not multiples of 2 and they are not even or different combinations. So let us try to find what must be the relation here. 2, 5, 10, 17. Let me tell you. First natural number 1. Square it. 1 square is 1. Add 1 to it. 1 square plus 1 is 2. Next natural number 2. Its square is 4. Plus 1, 5. Next natural number is 3. Its square is 9. 9 plus 1, 10. And next 4 square is 16. Plus 1 is 17. That means 1 square plus 1, 2 square plus 1, 3 square plus 1, 4 square plus 1. That means we can write the set builder form in this way. C is equal to set of X such that X is equal to N square plus 1. Every time 1 is added, N square plus 1, where N is a natural number, means N belongs to N and n is less than or equal to 4, up to 4 only. 1 square plus 1, 2 square plus 1, 3 square plus 1, 4 square plus 1. So the natural number is up to 4 only. So that is the way of writing set builder form. Now let us write some of the sets. Here what he is asking, list the elements of the following sets. So let us list out the elements in the set. First one, G is equal to set of all the factors of 20. So what are all factors of 20? Let us find in the rough column. 1, 20 is a 20. So 1 and 20 are the factors. Of course we know 1 and itself is compulsorily the factors of every number. Next, 2 tens are 20. Yes. And 3 is not a factor of 20. 4 5s are 20. Yes. And then 5 4s are 20. So 5k. So these are all the factors of 20. So let me write or list out the elements of the set, that 1, 2, 4, 5, 10 and 20. So all the factors of 20, 1, 2, 4, 5, 10 and 20. This set is the answer for that. Let's see the second one. What is saying in the second one? F is equal to set of the multiples of 4. We know the 4 multiples, 4, 8, 12, 16 like that. But the multiples of 4 between 17 and 61 only. So the multiples must be between 17 and 61, in between of these two numbers. And one more condition is giving here, which are divisible by 7. So they must be divisible by 7 also. First let me list out the multiples of 4 between 17 and 61. Between 17 and 61. 4 4s are 16, 4 5s are 20, 24, 4 6 are 24, 28, and then 32, 36, 40, 44, 48, 52, 56, and then 60. Because the multiple must be less than 61, so up to 60 only the multiples of 4. But what he is saying, one more condition, that these numbers, in this we have to sort out which are divisible by 7. So 7 3s are 21, which is not there. 7 4s are 28, yes, this number. 7 5s are 35, not there. 7 6s are 42, not there. 7 7s are 49, of course it is not there. 7 8s are 56, and 7 9s are, which is more than 60, right? So only two numbers are there which are multiples of 4 between 17 and 61 and divisible by 7. So let me write the set here. F is equal to set of 28 and 56. So we are not writing all the elements, all the multiples of 4. We are writing only those multiples of 4 between 17 and 61 which are divisible by 7. These two are the only two elements which are divisible by 7, right? Now let's see the next one. S is equal to set of X such that X is a letter in the word madam, M-A-D-A-M. So the letters in the word we are going to write here. But before writing, let us remember one thing, children, that in a set, if you are writing the set in roster form, the repetition of numbers or elements must not be there. So elements need not to be repeated. One time if you write, that is enough. Let me write the set here. S is equal to set of letters in the word. What letters are there? M, okay, comma, A, yes, and then D, yes, A. Of course I wrote already, so we are not going to write it again because there should not be no repetition, right? M, A, D, A I already wrote, and again M. M also I wrote already, so only 3 letters. That's it. So S is equal to set of M, A and D. These are the letters in the word madam. Okay. Next, last one. In this task, P is equal to set of X such that X is a whole number. Children, we must know what are whole numbers. 0, 1, 2, 3, so on. Right. So X is a whole number between 3.5 and 6.7. Children, they have given real numbers and in between of them what whole numbers are present. Let us write here. So P is equal to set of, after 3.5 the whole number is 4. Yes. Next 5. Next 6. Before 6.7, 6 will be there. And 7 is beyond 6.7, so we are not going to write that one. So answer is set of 4, 5 and 6. Now the second bit, what is asking us to practice? Write the following sets in the roster form. So we have to write them in roster form. Children, we have learnt already that how to write a set in its roster form and set builder form. Now in this task we have to write the sets in roster form. Okay, the first one, let's see here. B is the set of all months in a year having 30 days. So B is the set of all the months. So we know months, there are 12 months, January to December. But we need to write all the months, all months in a year having 30 days. Children, this is the condition. A month with 30 days they have to write. So how to know whether the month is having 30 days or not? So there is an interesting technique which we have learnt in our primary classes by our teachers, that see, by folding a hand like this, you can find which month is having 30 days or 31 days. Let's see here. January, 31 days. February. See children, February is a special month which will have only 28 days, and in a leap year it will have 29 days. January, February. March, 31. April will have 30 days. So let me write here, B is equal to set of April over May, 31, June, 30 days, and then July, 31, and again August, 31, September, 30, then October, 31, November, 30, December, 31. So November will have 30 days. So April, June, September and November are the months with 30 days in them. Okay. And now let's see the next one. P is the set of all prime numbers smaller than 10. So we have to write the prime numbers which are smaller than 10. P is equal to set of all the prime numbers. Prime number starts from 2. 2, 3, 5, 7, and the next prime number is 11, but we need to write smaller than 10. 11 is more than 10, so we are not writing 11, up to 7 only. Let's close the set. So this is the required set in its roster form. Now third one, X is the set of the colors of the rainbow. Rainbow will have 7 colors, right? And there's a word to remember all the 7 colors in rainbow, which is called with GR, like this, with GR. 1, 2, 3, 4, 5, 6, 7. Yes. So what are the colors? X is equal to set of V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, and the last one, R for red. So these are the colors in rainbow. This A is the set of factors of 12. So A is the set of factors of 12. Children, what are the factors of 12? 1, of course 1 is factor for every number, 1 and itself, 1, 12s are 12. Next 2, 2 6s are 12. Next 3, 3 4s are 12, and again 4 came, 4 3s are, 6 2s are, and 12 1s are. These are all factors of 12. What is saying? A is the set of factors of 12. These are all factors of 12. Which one of the following is not a member of A? Which is not a member of the set A? Is 1 not a member of A? See here, 1 is a member of A because 1 is a factor of 12. Next, 4. Is 4 not a member of A? Yes, 4 is a member of A. Then 5. No, 5 is not a member of set A because 5 is not multiple of, factor of 12. 12 of course is a member of A. So our answer is C. 5 is not the member of A.